Good day, students. So again, we are here for another video tutorial in Mathematics 10. So we are now in week 4, lesson 4.3. So this is going to be the last lesson for week 4, and it's going to be about geometric series. Previously, we talked about how to find the nth term of a geometric sequence. And then you've also learned how to find or determine geometric means, or how to insert terms in between two non-conjunctive terms of a geometric sequence. Now let's proceed to our topic, which is about geometric series. But before that, again, let us recall the definition of a geometric sequence. No? Importante gid nga balik-balikon taning definition sa geometric sequence kay basically ang atong giisgutan karon gyud sa panantanan for this week is about geometric sequence. Geometric sequence is a sequence in which each term is obtained by multiplying the preceding term by a constant quantity. And this constant is known as the common ratio. Kinahanglan gini nato siya nga definition kay kung dili po geometric sequence ang atong makit-an, so we cannot use the formula nga atong paghisgutan karon para pagkuha sa iyang series. So what is geometric series? A geometric series is the sum of the terms of a geometric sequence. So i-add nimo ang mga terms sa geometric sequence, we call that the geometric series. Now, there are two formulae to remember when you're dealing with if you want to find the sum of the terms of the given geometric sequence. First is for finite geometric series. Finite, meaning there's an end to this sequence, no? And we're going to use this formula. S sub n equals a sub 1 times quantity 1 minus r to the exponent of n all over 1 minus r. And we can only use this formula if and only if your common ratio r is not equal to 1. Kinahanglan dili equal to 1 ang imong ratio ani. And for infinite geometric series, take note ha, infinite. It is possible really to find the sum of an infinite geometric sequence. And we're going to use this formula S equals a sub 1 over 1 minus r. But then again, we can only use this formula, or we can only find the sum of an infinite geometric series if your common ratio is greater than negative 1 but less than positive 1. Kung imong common ratio nimo kay mo equal na to 1 or more than 1, or it could be lesser than negative 1, like negative 2, negative 3 nga na, or negative 1 gud siya, then dili na ka makakuha og sum sa infinite geometric sequence, no? And kung imong nabantayan, ang atong denotation is just S, no? Kay infinite naman so to infinity na siya. Wala na tay n, kay n ra na siya kung pananglitan, naa siya end ba? Natay n, finite siya. Okay. Now, let's go to our virtual board to solve problems involving arithmetic series. No? Let's go to our virtual board. Okay, first problem is here. We're going to find the sum of the first 9 terms of the geometric sequence, 9, 36, 144, 576, and so on. Okay, klaro kayo no nga sa problem na to, ang gipangita is the sum of the first 9 terms, meaning to say we are dealing with a finite geometric sequence here. So what formula are we going to use? We're going to use the formula S sub n equals, that was a sub 1 times 1 minus r to the exponent of n all over 1 minus r. So we're going to use this formula. Now, take note. Since we want to find the sum, we're going to need all these, no? We're going to need a sub 1, we're going to need our common ratio, and our n. So now we identify the given. What are the given? We have a sub 1 in there, no? Or a sub 1 that is equal to 9. And our common ratio also, no? So for the common ratio, all you have to do is to choose any 2 consecutive terms, no? For this case, we're going to use the a sub 2 and a sub 1. And then again, kinahanglan si a sub 2 na as dividend ang divisor si a sub 1 to find the common ratio. What is your a sub 2? That is 36. That's divided by your a sub 1, which is equal to 9. Hence, our common ratio should be equal to 4. Now that we have our common ratio, napatay kinahanglan lain, no? We need n. Pila may value sa atong n, ani? It should be equal to 9. Nganong 9 man? Because we want to find the sum of the first 9 terms of this geometric sequence. So S sub 9 is the unknown here. Now that we have all these information, now we're gonna substitute all these, the formula. So S sub n becomes S sub 9. That's equal to your A sub 1, which is 9, times quantity 1 minus, or your R is 4, to the exponent of n, which is 9, all over 1 minus R. Now from here, we simply copy 9, no? And then 1 minus, you cannot subtract them yet, no? Kaya napaman siya exponent. What is 4 to the exponent of 9? 4 to the exponent of 9 is equal to 262,000, 144. Lupad ng kung lupad ng maayo. Numbers. Okay? That was 262, right? So 262,144. And then all over 1 minus your R, which is balik to dire, no? Ang atong R dire kay ato na ning substitute nande. Okay. No? So your R is equal to 4, no? And then what is 1 minus 4? 1 minus 4 is equal to negative 3. And that's equal to 9 times, what is 1 minus 262,154? So, kuhaan ra ninyo mo siya 1, and the answer will be negative, no? Kay mas dako good. Ang gamay mas kuhaan og dako, so ang resulta is negative, no? So that is negative 262,143. Kuhaan man nato siya 1, no? All over negative 3. And from there, you're going to multiply 262,144, negative 262,143, times 9. And that would be 2,359,296. And we're going to divide that. That's negative, by the way. No? Okay, positive times negative is negative, divided by negative. So your S sub 9, therefore, our S sub 9 is equal to, what is negative 2,359,000 divide 296 divided by negative 3. So negative times negative divided by negative is a positive number. And the answer is negative 786,432. So the sum of the first 9 terms of this geometric sequence is 786,432. Can you just imagine 9 terms good na? Ang iyahang common ratio is 4. So times na po nimo siya 4 times na 4. I-add na nimo silang tanan. Surely maabot ginig 786,432. So that's how the formula works, no? Okay. Next example. So for the next example, we're gonna make our own. Okay. What if your sequence goes like this? 3, 3, 3, and so on. So in fact, tanan nga terms ana kay 3. No? Question, is this a geometric sequence? Yes, this is a geometric sequence with a common ratio of 1, di ba? Geometric man na basta pananglitan ang iyahang mga succeeding terms kay nakuha sa pag-multiply, no, og certain number, no. And ang atong common ratio is 1, no, kay 3 times 1 3 nya, times 1 upon 3 times 1 upon 3 and so on, no. So your common ratio here is 1. What if we want to find the sum of the first 8 terms of this geometric sequence? Question, can we use this formula? S sub n equals a sub 1, kanisang formula? No, we can't use that, no? Sama na sa akong giingon sa katong kaganiha, ito dapita sa pag-introduce na ako sa aning mga formula, kining you cannot use this formula kung ang imong r is equal to 1. Nga naman, what happens is that when your r is equal to 1, this denominator here becomes 0, and if your denominator is 0, this whole thing becomes undefined, no? Ma-undefined siya. So, may buhaton na to ani. So, instead, atong i-add ni sila tanan dito, no? Kutob sa 8 nga terms, no? So, ato pa di ay to find the 8 sum of the first 8 terms of this. Mo add ka 3 plus 3 plus 3 plus 3. Pero kabantay ka nga, ang imong gi-add kay parehas ra tanan, no? Kung mobalik tas inyong pagka-elementary, repeated addition is what we call multiplication, no? So, i-shortcut na lang nato, no? Ato na lang siyang i-multiply. So, pila ka buok 3 ang atong ipang-add diri? There are 8 3s, kuno kay 8 man ka buok ang atong sum of the first 8 terms man. So, that would be 8 times 3. And that's equal to 24. So, sa ato pa ay the sum of the first 8 terms of this geometric sequence is equal to 24. And then naapot tayo na found out ani. Thus, if r is equal to 1, when your common ratio is equal to 1, since di man ka makagamit atong formula di ay, then, the sum of the first n terms is just equal to your n, di ba? Kabantay ka, 8, 8, no? That's your subscript, di ba? Your n times that is your a sub 1. A sub 1. No? So, in other words, if you want to find the sum of the terms of a geometric sequence, given that its r is equal to 1, all you have to do is to multiply n and your a sub 1, and that will be your sum. Okay? For example, ang imuhang geometric sequence nimo is, let's just say 5, dayon 5, dayon 5, and you want to find the sum of the first 10 terms. So, ano na siya? 10 times 5. So, pila may sum ano niya? That's 50. Ano ka simple, no? Ano na siya? Okay? This will only work, pod class, if your r is equal to 1. Let's have another example, no? The third example. What if your sequence goes like this, no? Kaya kani mga special nga cases mo guni siya good. Let's just say we have 4, and then negative 4, and then 4, then negative 4, and so on, no? What if your sequence looks like this? First, is this a geometric sequence? Definitely it is a geometric sequence with a common ratio of negative 1. Negative 1 ang common ratio ani, di ba? Kay di ba kung ang first term 4, nya multiply yan mo negative 1 ang answer, negative 4 man. Nya negative 4 times negative 1, di ba? Positive 4. Nya 4 times negative 1, di negative 4. Di ba na sila common ratio? And the common ratio is equal to negative 1. What if in that sequence, you want to find the sum of the first 6 terms? No? Question. Can we use this formula? Yes, no? Yes. Ganun maka-use man ting ang ani nga formula because our r is not equal to 1 naman. Our r here is negative 1 man. So, lahi raman si negative 1 o si 1. So, we can use that formula. Pero instead, let us find another way of solving this, no? Find another way. Let's investigate, no? Now, ato ko na siyang ibinagsak, no? Kung i-add na to sila tanan ba? S sub 6 equals unom kabuk nga terms nga nino, unom kabuk terms ani kutob, so that would be 4 plus negative 4 plus 4 positive na pud sunod, no? Then plus negative 4 na sad. Pila na upat na siya kabuk, no? Uno man dapat. This is negative. So, plus 4. Yeah, plus negative 4 na sad. Diba? 1, 2, 3, 4, 5, 6. 6 ka terms. What is 4 plus negative 4? Diba 0 man na siya? No? Ang 0 na. 4 plus negative 4, 0 sa na siya. No? 4 plus negative 4, 0 sa na siya. Sa ato pa day, the sum of the first 6 terms is equal to 0. No? 0 day ang answer na niya day. The sum of the first 6 terms of this is 0. Basig mga na mo, uy, galis-lisod, hinunta, kag gibinagsa man na nato pag-adad. Sige lang, unya na. No? atong iusa ang conclusion nato ani no nga yang shortcut nga pamaagi ba if your r is equal to -1. Now, what if you want to find the sum of the first 5 terms? S sub 5. So, sang S sub 5, pareha ra gid po din. Gaba. S sub 5. Sagdi na S, goodness. S sub 5. So, may mo ni siya 4 plus -4 plus +4 plus -4 plus 4. No? 1, 2, 3, 4, 5. 5 naka-terms. No? If we add 4 and -4, that is 0. 4 and -4, that is 0. What remains is 4. Sa ato pa, the sum of the first 5 terms of that sequence is equal to 4. Na may nabantayan? Diba, nakabantay mo? Kung pananglitan, maparis gani ang terms gani, 0 gid siya. No? Pero kung dili gani paris ang term gani, ang mahibilin ana niya nga numero is kadtong imong first term. Di ba? So, sa ato pa na natay nakuha ang conclusion, no? Thus, or let's say hence na po itong gamiton. Hence, lahi po ba? If r is equal to -1 and n is even, then S sub n is equal to 0. It is automatically 0. Kung ang imong r nimo, common ratio is -1, and your n is even, maparis man sila tanan. Nya, kung maparis pa 0 man, di ba? So automatically, the sum is 0. So for this case, kung pananglitan ay moingon ka nga, what is the sum of the first 3,000 terms of the sequence? 3,000 terms, ha? Now, if you're going to use this formula instead of that way, instead of ingani na pamaagi, imagine na, ang imong n mo diri kay 3,000, sus maluya kay magswagit siguro ka, surrender ang calculator mo, no? Kay dako na kastanan nga numero, no? So, instead, we will use this one, this idea nga. If your r is -1 and n is even, then S sub n is equal to 0. Karon, the sum of the first 3,000 terms, 3,000, even man na, di ba? Paris man na, 3,000 ka terms, that is your n. Paris man na, ato pa ang sum ana, 0 gina, no? Sa pa nakadako na siya, 0 gina siya gid. Now, but, you say, if r equals 1, but, if r is equal to -1, and n is odd, no? Like this one, S sub 5. Then your S sub n is automatically equal to your A sub 1. Bantay ka mo, balik ka rin yung A sub 1, o sa kanang kuan, basta add siya. So what if, mangutana, what is the sum of the first 573 terms of the sequence? 573 terms, ha? Tapos bisag unsa pa nakadako ng imong n nimo. Kung dili gani pares, ito ganito gingon rin. Kung dili pares, if n is odd, then your S sub n is equal to A sub 1. So kung 573 ka terms, i-add nimo ani, pila ang imuhang S sub 573? That is just equal to 4. So it's as simple as that. I hope nga inyo ni siyang kanang nasabtan no nya inyo ni siyang timan-an. Okay? Not necessarily kinig nga formula imong gamiton permanente, no? Pero for special cases again siya. If your r is +1, kini nga pamaagi, then n times A sub 1. If your r is -1, then duha ka cases na. Kung even gani, 0 ang sum ana. Kung odd gani ang imong n, then ang sum ana is your A sub 1. Mabalik ka siya sa A sub 1. Okay? Now let's proceed to the final example. This is our fourth example, no? Consider the infinite geometric sequence 1, 1/2, 1/4, 1/8, and so on. Find the sum if possible. Kung sa ganito yung formula na to ato, the formula was S equals A sub 1 over 1 minus R. So, kadali agad sa formula, no? Pero let us remember nga, we can only use this formula if your r is greater than negative 1, mas dako siya kaysa sa negative 1, meaning to say, ari na siya, padulong na siya sa 0, no? Negative 1. Negative 1, so sa ito pa, mga negative point something, mga decimal na, mga fractions na siya. But it should be less than positive 1. So, okay, less than positive 1, mga positive po na nga mga fractions po. No? Okay. So, first, let's identify kung pila ang yung common ratio. No? First, we need to find the common ratio. No? Okay. Anha man ta makahibaw kung mamaubitan na nga sa atong problem na siya, find the sum if possible. Okay, possible raman siya kung makapasar siya atong nga condition nga ang iyang common ratio should be greater than negative 1 but less than positive 1. So what is our common ratio here? Our common ratio, let's use a sub 2 divided by a sub 1. No? What is our a sub 2? Or a sub 2 is 1/2 divided by your a sub 1, which is 1. Sa ito pa, this is 1/2 divided, ato lang ning siyang i-upurma ha, divided by 1. That is 1/2, di ba kung panitan ning ani, mag-divide ka ni kay kuan man ning reciprocal ni man niya. Ang reciprocal sa 1, sa paggulibaling 1 ra gid gihapon na. Yan, the operation becomes multiplication. So 1/2 times 1 is 1/2. Therefore, our common ratio is 1/2. Karon, we have the common ratio which is 1/2. Nakapasar ba siya sa katong condition nga your r should be greater than negative 1 but less than positive 1? Yes, pasar kayo, di ba? Mas gamay siya sa positive 1. Pero, mas dako pa siya sa negative 1. Sulod siya. No? Therefore, it is possible to find the sum of this geometric sequence, or this infinity niya. Question sa ba? Why is it possible to find the sum of an infinite geometric sequence? Grabe, infinite ha? Dili mo undang. Pero ano posible man siya? I'll show you why. No? For example, we have 1/10. Geometric sequence na kanilang akong igamit kay mas dali siya nga makita. 1/10, that's equal to 0.1, di ba? And if this is geometric sequence with a common ratio of 1/10, then the next term should be 1/100. No? And that is equal to 0.01. The next to that would be 1/1000. Times na natugtog 1/10 kada usa niya. And then this is 0.001. And the next to that would be 1/10,000. No? And that would be 0.0001. In fact, kung magkaduol ni siya infinity kini siyang nasa ubos, magkadako na siyang maayo, kini dire mo approach pud na siya to 0, no? Mo approach magkaduol sa 0, ha? Magkadako ang denominator ani dire, magkadako magining denominator ani kay geometric sequence, multiplyan ba ina, no? Multiplyan unya. Fraction man ang atong kuan ani, ang atong ratio ani, di ba? Kay ngano dapat si ratio is greater than negative 1 but less than positive 1. Magkaduol gid na siya sa 0, magkadako ni denominator, magkaduol na siya sa 0, no? Magkaduol na siya 0. So kay magkaduol man na siya 0 di ay kini nga mga numbers diri kung imo ni siyang i-add pud tanan diri, this will also approach to 1. Moduol pud na siya sa 1. So maximum nga sum ani niya will be 1. Okay? Mao nang posible gid nga makuha ang iyahang sum sa infinite, no? Sa infinite geometric sequence with this condition. Ngano man kay kung imo nang i-add kini nga mga fraction class, kung imo ni silang ipang-add tanan, approximately this will, the sum of this will approach to 1. Padulong ra gid na siya sa 1. Di na siya mulapas ni 1. Mao na nga posible nga makuha kay ngano. Usa ra may padulong nga niya. 1 ra man. Okay? So, I hope nga nasabtan sa do. Okay? So, the given are our a sub 1, no? Ang atong kinahanglanon ani nga formula a sub 1 ug r ra man. Ang atong a sub 1 is equal to 1. So this is S equals, what is our a sub 1? Our a sub 1 is 1 over 1 minus our r is 1/2. No? And this is 1 over 1 minus 1/2. Ang piso kwaag si kwintas tabos, di ba? Ang answer ana sa kwintas tabos, pila mas kwintas tabos? That's 1/2, no? Ang 1 kwaan og tunga, 1/2. Huh? Ano? And this is 1. Anak man na. Ato raning usbon og suwat ha. Ato raning usbon og suwat. Basta maglibog mo ba? Kaya itong kanon ba? Now, this becomes 1 divided by 1/2. Diba? Maura na. Pero actually, kini siya, maura ning purmaha kaniha. Kining venculum lang diri, akong gihimo og divide kay division, man gina. Diba? That is equal to 1. And we know for a fact that when we're going to divide fractions, the divisor, what you're going to do with the divisor is that you get its reciprocal, no? Reciprocal, and then your operation becomes multiplication. Mahimo siya multiplication. Na mahimo na ni siya og 2/1. No, balihon man na nimo. And di ba kanang 1 ang kung fraction na siya 1/1 na magyapon na. So 1 times 2, that is 2. 1 times 1 is 1. So the answer is 2. So the sum of this is equal to 2. No? Okay. In fact, kung imong tan-awon diri no, mao ni akong gisulti ninyo. Kini sila nga mga fraction diri, kung i-add na nimo sila, mo approach na sila to 1. Kung ipang-add na nimo tanan diya ba? 1. Yan na nagug kay 1 diya daan, di ba? Makita ra pa nimo ba? 1 plus 1 dito. Yeah? Mo na siyang it's possible to find the sum of an infinite geometric sequence. Okay? So I hope nga nasabtan ni siya nga discussion, and I hope nga makatabang ninyo sa pag-answer ninyo sa inyong module. So next week na sad. So let's meet again next week. Bye for now.